The ESP32 S subfamily is currently represented by single-core S2 and double-core S3 chips. Compared to the generic ESP32 family, the S series represents a newer LX7 architecture and higher performance using the same maximum processor clock. The S family has much better instruction cache performance compared to the generic ESP32. As with all ESP32s, the S family provides hardware-accelerated security features such as random number generator, unique ID, hardware-accelerated encryption, decryption, and hashing. This highly integrated chip includes an antenna interface with a switch balloon and power management converter, Wi-Fi, Bluetooth 5, and Bluetooth Low Energy interfaces. The main 1 or 2 core processor, a third ultra-low power core, static RAM as data memory, flash memory for storing programs, a real-time clock, cryptographic hardware, and interfaces. The ESP S2 chip doesn't have a Bluetooth connectivity, only Wi-Fi is provided. Let's describe individual blocks in more details. The central processor is a Tensilica Extensa 32-bit LX7 microprocessor with 1 or 2 cores, depending on variation. The processor clock frequency is up to 240 MHz. Ultra-low power coprocessor has a new architecture that even lowers energy demand. The ESP32 S2 single-core in-chip memory consists of 128 KB of ROM for booting and core functions, 320 KB static RAM for data and instruction, 16 KB RTC static RAM for data storage and main CPU during RTC boot from the deep sleep mode. Depending on the chip, 0, 2 or 4 MB of the flash memory can be included. Depending on the chip, 0 or 2 MB of the pseudostatic RAM can be included. The ESP32 S3 double-core in-chip memory contains slightly more resources and consists of 384 KB ROM for booting and core functions, 512 KB static RAM for data and instructions, 16 KB RTC static RAM for data storage and main CPU during RTC boot from the deep sleep. Depending on the chip, 0, 4 or 8 MB of flash memory can be included. And depending on the chip, 0, 2 or 8 MB of pseudostatic RAM can be included. External memory can be added via Quad SPI interface on the development boards up to 1 GB, which with access up to 11.5 MB each time for S2 and 32 MB for S3. ESP32 S2 has 43 GPIOs and ESP32 S3 has 45. It is worth mentioning that besides the interfaces mentioned in the generic ESP32, the S family has also support for USB on the go, DVP parallel camera interface, LCD serial and LCD parallel interfaces. The S3 version also has an SDMMC host controller interface. Compared to generic ESP32, S3 has better analog to digital converters and S2 has digital to analog converters. Both S2 and S3 also have more advanced and better security mechanism and faster boot. On the other hand, the number of LED PWM channels and pulse counters has been lowered. For rapid prototyping, developers can use ready-to-use kits with ESP32 chips. The most popular are ESP32 S2 DevKit C, ESP32 S2 DevKit M, ESP32 S3 DevKit C, ESP32 S3 DevKit M, M5 Stamp S3. There are many more, including boards with integrated displays, user interface components, radio coprocessors such as LoRa, battery management, and sensors. It is worth mentioning that the ESP32 S3 Pico chip has all necessary functions integrated in the single enclosure, including an oscillator, decoupling capacitors, SPA flash, and pseudostatic RAM, which enables hardware developers to build compact and small systems. This way, almost all components but sensors are included in a tiny enclosure, limiting the size of the IoT device and presenting better energy efficiency. Many ESP32 S series models are available in two variants, with a built-in PCB antenna only and a version with an additional IPX connector for an external antenna. Models with external antenna also have a built-in PCB antenna that is automatically switchable when an external antenna is present. The second option is valuable in environments with limited connectivity and longer distances between devices and routers, but it uses a bit more energy.